Okay, this is 5.10, mass in different systems. So we're going to be comparing metric mass or weight to imperial mass and weight. So let's start off with try these. Circle the metric units, underline the imperial units. Okay, so pound is imperial, so we're going to underline it. A gram is metric, so we're going to circle it. A ton with an NE on the end is metric, so we're going to circle that. An ounce is imperial, we're going to underline that. This ton, T-O-N, is an imperial US unit, so we are going to underline that. And kilogram is a metric unit, so we're going to circle that. Okay? All right, let's get right to an example. A hockey puck has a mass of 6 ounces. What is its mass in metric units? Okay, so let's see. We've got ounces, and we want to go to the equivalent unit, which is probably a gram. So we know that 1 ounce is the same as 28.35 grams. We have 6 ounces, so let's do the math on that. So what is its mass in grams? Well, we know 1 ounce is the same as 28.35 grams, right from the chart above, right here. Okay, so 6 ounces times 28.35 grams per ounce gives us an answer of 170.1 grams, or about 170 grams. Okay, so what is its mass in kilograms? Well, let's go back to the chart. 1 gram, we look up here. No, we don't. 1 gram is the same as 0.001 kilograms, because we know it takes 1,000 grams to make a kilogram. Okay, so it's going to be 0.001 kilograms. So 170 grams multiplied by the conversion ratio of 0.0001 kilograms per gram gives us an answer of 0.17 kilograms. Okay, 0.17 kilograms. All right, example 1. The greatest mass of Albertosaurus was about 1.9 tons. What was its greatest mass to the nearest tenth of a ton US? Okay, so what is the relationship we'll use? Well, 1 ton is equal to, well, let's go back up to our chart here. 1 ton is equal to 1.10 tons, because that small t is SI, the large T is US tons. Okay, so we know it takes more American tons to make a metric ton, so 1 metric ton or 1 SI ton is 1.10 imperial tons. So we're going to use that 1 ton is 1.10 tons. Okay, so what is 1.9 tons in US tons? Well, 1.9 times the conversion ratio of 1.10 large T tons to small t gives us an answer of 2.09 US tons. The greatest mass of Albertosaurus was about, well, we can round to the nearest tenth, let's say 2.1 tons. Okay? Solution number 2, well, there's always 2 ways to do it. We know that we want to have an answer in American tons, which is capital T. Okay, and we know we're starting out with 1.9, okay, 1.9 metric tons. So the conversion ratio is it takes 1.10 US tons for 1 imperial ton. Okay, so the conversion ratio is 1.10 to 1 again. We're going to multiply that by 1.9. Okay, conversion ratio, and we get the same answer of 2.09 US tons, so about 2.1. Okay. Reflecting. Should the number of US tons be greater or less than the number of metric tons? Well, it should be greater. Okay, because it takes more US tons in a metric ton. Okay, so let's go to the next example. Ashley, a fitness coach, calculates body mass index, or BMI. BMI is just a number that's used to determine how much body fat a person has, and it's just a comparison between a person's mass or weight to their height in pardon me, in meters. Okay, so mass in kilograms to height in meters. So she uses the formula to determine if a person is in the normal range of 18.5 to 24.9. Is this client within the normal BMI range? Okay, so to do that, we have to look at the information that's given to us first. First of all, her height is already in the SI system. It's given to us in meters. It's 1.67 meters, so that's great. We've got the first part of the formula, the height in meters, but we need her mass in kilograms, and right now her mass is in pounds. So the first thing we need to do is we need to convert her weight or her mass in pounds to kilograms. So we need a conversion ratio. So 1 pound is the same as 0.45 kilograms. You can look at your conversion charts for that. So 120 pounds times 0.45 kilograms per pound gives us a mass of 54 kilograms. Okay, so now we have all the information we need. So we've got our mass in kilograms, which is 54. We've got our height in meters, which is 1.67. So we'll just put in 54 in this box right here, and we'll just get our calculator out, and we will do the calculations. We take 54 divided by 1.67. You can hit equals when you do that, and then divide it again by 1.67. Or you can multiply 1.67 times 1.67, get a number, save it, take 54, divide it by that number, and you're going to get an answer of 19.36 as her BMI, or body mass index. Is the client within the normal BMI range? Well, the client's BMI is 19.36. This is greater than 18.5, so that's good. She's not underweight. And it's less than 24.9, which is the high end, so she's not overweight, so her BMI is well within the normal range. Okay? All right, so go ahead and do the practice for this one, and then I'll see you on the next unit.